All right, number 11 is one of those dreaded transformation questions, but it's really not that difficult. The linear function f of x is graphed on the coordinate plane below, so we know this is linear because there's no x squared. The graph of the new line is formed by changing the slope of the original line to 2/3. So that's going to be g of x is going to be equal to 2/3 x. And the y-intercept is changed to 4. So that's going to become plus 4. Which statement of this relationship is true? So we know that this is going to be translated 4 units up. So that can count out A, and that can count out D. Now, the line of the new line is less steep than the graph of the original line. 2 divided by 3, excuse me, is less, so our A value is less than 1. So we know that when our A value is less than 1, then it's going to be less steep. Our graph is going to become compressed. So this is going to be less steep. So we know our answer choice is B. Number 12, the graph shows ordered pairs of the belonging to the quadratic function h. What is the range? Now range, that means we need to find vertex. Right? So now I'm going to look for symmetric pairs of my y values. I have a symmetric pair here, and I have a symmetric pair there. So my vertex is right here at 3, -8. So my range is going to be y greater than or equal to, wait, hold on. We need to determine if this is a minimum or maximum. No, not necessarily. We don't have to, because there's no, it only gives us, so our y value is -8. So we know that this is going to be a positive, so it's going to be y is greater than or equal to -8. So that means that it's a minimum. But we can check. So if we look at our values of our y values as we go away from our vertex are getting bigger. As we go from -7 to 1, that's getting bigger. From -7 to 41, that's getting bigger. So that means if I were to talk about looking at a graph and talk about where that is at the vertex, so it's 3, -8, so that's going to be somewhere down here. So we know that if I were to look at my values of y, they'd be increasing along this graph, increasing along the values of my parabola. So I know that this is a happy parabola, so it's going to be a minimum value. I'll see you in the next video.